and thank you for contacting Wave Support. I see from your clinical request you have a patient who has slightly larger than average pupils, and you're running into some glare issues. And for this case, you didn't quite specify, but I'm assuming you mean glare mainly in poor lighting, as opposed to just glare in general from being out and about. And we'll talk a little bit about the two of those. But if we look at your patient here, from my understanding, you have pretty large pupils, and if we look at this topography, you'll notice we have this little steepened area that probably corresponds to about 7 to 8 millimeters. And so I like to kind of look at these patients as almost a refractive patient, where you have, instead of being a perfectly nice smooth cornea, we have this distortion kind of going through this transition zone in the cornea. When the pupil gets larger, we're probably getting some extra distortion from that little area through there. So the question is, how do we fix that? And if I look at your design, this actually looks very nice, and I'm glad to hear you're successful with this large diameter lens. One of the things you'll notice, though, if you look at this back surface of the lens here, and if you look at this this optical back surface optical zone, if you get out to about here, right at about somewhere around 7.5 or so, 7.5 almost, so around that area, you start to get this little back curvature change. So if we get our pupil larger than this area, and it sounds like we get in that area, we're probably getting some distortion from this part of the lens, and of course and also this cornea here. So in a scleral design like you have, of course you got you're vaulting the cornea, and you would intuitively think that the tear film would neutralize any distortions in this cornea, but as you know, working with corneas throughout your career, you probably know, like I know, that quite often these rules go out the window and they're not always so hard and fast. And so one approach is to assume that we can get a larger, the tear film will neutralize any corneal difficulty there. And one way to do that is just try to get this little bit larger, this area. So if we're at about 7.5 or so, what you want to do is just get it larger. The easiest way to do this is just take this optical zone and go a little bit bigger. So if you're 12.6, you can actually, if you slide this out here to about, we'll go about 1 millimeter out and see what happens. If you go out to a 13.6, you end up with a lens that still actually looks pretty nice here. You've reduced this little landing zone, but it sounds like you have a pretty nicely fitting lens to begin with, and that little change probably won't change a whole lot as far as the fit goes. But if you look at what we've done now is we've moved this optical zone out to about 8.5. So now you've got a little bit more uniform area before you get the curvature change here. And so in theory, that should give us a little bit larger optical area and a little bit less distortion. And so that would probably be your least amount of change you can make to try to address that glare issue from this large pupil. Another thought would be, instead of using the tear meniscus or the tear film to neutralize that area, the question is, should we just put a lens right on there, just go with a corneal lens? And sometimes if you go to, I know you like the scleral design, maybe just go to a mini scleral or a semi-scleral design where it's really more of a corneal touch lens that's a small diameter, and that way you actually use the lens itself to try to round this area out a little bit more to see if you can physically change it, not just completely rely on the tear film. There's a little tutorial. It's a nice wave tutorial. I don't know if you've seen it yet. I'll include it in the email. It shows exactly how to go about designing a lens. If you were to try that, I'd go about a 13.5 or so lens. And the other thought, if this individual struggles a lot with glare, you might even try some tint testing. As you know, some of those brown lenses sometimes will help cut glare and haze a little bit more from the high energy visible light out there, the blue light. And if you find that somebody responds nicely to that, you may be able to get away with going with a little smaller lens around 13 to 13.5, and maybe doing like a fluoroperm 60 with a brown tint to help cut out some glare. That might cut down with daytime glare if it's a person who's a little photophobic, as opposed to just sensitive to glare from a large pupil. So that's just a little side thought you can try. So just to summarize that, the easiest thing to do is take your lens, just increase that back OZ just a little bit, and I think that'll get you a little bit more workable room here before you get this little change in the back surface. I would try that first, and then and hopefully that'll get you where you need to be. As far as the bifocal add, that of course doesn't make a whole lot of sense. As you know, if we put a bifocal in here, we're probably going to get some interaction with this optical zone. And you didn't quite specify whether it was a center near design or a center distant design. Certainly, if you're not successful doing this, you could certainly try and incorporate operating a little bit of bifocal. If that's the case, you may want to see if you can sort of simulate the size of what was in that the soft lens that you were working with. So anyways, I wish you well with this case. It's a challenging one. These large pupil cases are always a bit of a challenge. But think of it in terms of sort of that post-operative um, RK, or rather post-operative PRK or post-operative LASIK patient as a better example with a patient who has large pupils. Kind of think about it in in those terms, that might get you there a little bit faster. So good luck with this case, and thank you for contacting Wave Support. Have a great day.